A lot of people love building DIY pedal kits like this StewMac Screamer kit, but I think there's a way we can do it without actually making something like everyone else builds. We can do it completely different pretty easily. But first, we need a change in here. All right, that feels a lot better for this project. So we're going to start with the StewMac kit, right? This is the Screamer kit. So it's based on like the Tubescreamer circuit that we're all really familiar with. However, we're going to take my favorite little tool to create circuits with, the Breadboard, and we're going to make some different circuits from it, but still use the kit to build a finished pedal. Let's get into it. So before I get started here, if you like this kind of stuff, make sure you check out one of my other sites, guitarpedalcourse.com. Just go right here to the Complete Beginner's Guide, How to Design Your Own Guitar Pedal Circuits. Click on that and you'll see my ugly face right here, and then all the different types of videos and curriculum that we go through. There's over 7.5 hours worth of video, which is really going to show you kind of everything I'm going to show you here, which is these are all circuit blocks. And we can take these circuit blocks, and if we can recognize them in a schematic, we can then, when you go buy a kit, you can take that kit and you can change that kit into all kinds of different things. So even though I'm using the StewMac Screamer on this particular video, which is just a straight up Tubescreamer clone, we're going to turn it into something that does not sound like a Tubescreamer at all, even though it's topology-wise, looking at the topology, it looks like a Tubescreamer. But it doesn't really mean that much if we can recognize the blocks, change them how we want them, and give us something and build something for ourselves that is inspiring to play and also fun to build. But the course is really going to walk you through everything. So we're going to talk about how to even read schematics, what all the parts actually do and what they look like. We're going to talk a little bit about soldering and using a multimeter because that's important. Then we're going to start with some super beginner projects. And then we're going to go on to a little bit more advanced stuff, still beginner, still very beginner based. So we're going to go through buffers, some gain stages, a little bit of op-amp stuff, some tone control stuff. And ultimately, it's going to give you a lot of knowledge that you may have always wanted to know. And this is really tailored towards someone that has no idea anything about electronics. So if that's you, you'll love it. So let's get on with it. Let's talk about this circuit that we're going to do. So this right here is a basic schematic of a Tubescreamer. This is what the Tubescreamer looks like. What we have is a buffer that goes into a non-inverting op-amp, basically just a gain stage, into a low pass filter, which just takes away some highs. Then the Tubescreamer tone control, which takes away some highs when it's down and adds some highs when it's up. That into a simple volume control, that into another buffer, and then it goes out to your amplifier. But let's look at another circuit that's basically identical as far as topology goes, which is the Boss SD1. Now, even though they sound different, topology is pretty much the same. Input buffer, non-inverting op-amp, low pass filter, tone control that does the same thing, set up the exact same way, level control, volume control, whatever you want to call it, and then a buffer, and the signal goes out. Same exact thing. The only difference is this is all electronic switching stuff, so we're not going to mess with that in this video, but this is all that other stuff here is just electronic switching that makes the Boss turn on and off the way it does. It doesn't affect the sound much at all. But let's compare that to a completely different sounding pedal, but still pretty much the same thing, is the LovePedal Eternity. Now there's a bunch of different eternities. This is the Burst. And so it's simplified, but it's still kind of sort of the same. We're missing a buffer, so there's no buffer here on the input, but we have that non-inverting op-amp. We have that low pass filter. We have that same type of tone control. We have our volume control out. And of course, our signal goes out from there. Now, we're not going into a buffer, so there's no buffer here, but it's basically the same sort of type of thing, even though it sounds quite a bit different, really. And a good friend of mine, Jamie from Earthquaker Devices, came out with the Plumes. Now, I love this example because while the topology is basically like a Tubescreamer, it sounds nothing at all like a Tubescreamer. And I love that about it. That's not a slam at all. I actually really love the fact that he took this topology and made something completely different and made it all his own. I love that. But we have a buffer. Now this is an op amp buffer, so it's a little different type, but it's still a buffer on the input. We still have this non-inverting op amp stage. He's doing some other diode tricks in here, but we still have this non-inverting op amp stage. We still have this low pass filtering. We have this same type of tone control. We have the level control, and then we have another op amp style buffer, and that goes out. So same type of topology completely, but it sounds radically different. Let me show you what I mean. To really get a feel for these different types of pedals, even though they're the same topology, let's play through them real quick. We're gonna start with the Tubescreamer. Now we're going to try something a little bit different. So I have created this circuit on this breadboard, and it looks a little messy, I know, but it is basically a Tubescreamer topology, but I've voiced it to sound completely different. So let's run through that. I'll give you the schematic in this as well, so if you want to breadboard it yourself, you're more than welcome to. And like I said, this is the type of stuff that I'm teaching in that course. So if you love it, check out the course, and enough plug-in for me. So here we go. Let's go with the Tubescreamer first, and we'll kick on the breadboard. Let's check out the schematic that I'm using on this, because I just threw it together pretty quick. So I spent about 30 minutes putting it together, trying to make it sound somewhat decent, but I'll show you what I did, and then we'll actually put this circuit into that StewMac kit, and it'll be a pedal that we can play. So let's compare what I have on my schematic. So again, we have the same non-inverting op amp. This is the gain stage. We do not have a buffer. I'm not going to use the buffer. This is just audio signal going into my circuit lab. We have a slight low pass filter, same type of tone control, same volume. And I'm going to go ahead and keep this output buffer there. So it's good to have. I think it's a good influence on the sound, and I want to keep it. That's basically it. So even though it sounds completely different, this is the schematic. So if you could build this right now with a breadboard if you have it, just by using the values, putting the values on the parts with those values on your breadboard, and you could play this right now. So for comparison's sake, here is the schematic of the StewMac Screamer. Again, you can see here's the buffer, non-inverting op amp stage, low pass filter, tone control, volume, and output buffer. Comparing that to my schematic, hopefully you can see the similarities. It's nearly identical in topology again. So, all right. So with that, I think it's time, let's go ahead and build it. I think it's time to put it on the StewMac kit breadboard, or StewMac circuit board, and let's build this thing. All right. So the first thing we have to do is, here's the box of stuff. We have to unbox everything, of course, and we have to figure out on this circuit board, we need to figure out what part goes to where. So with that, we're probably going to need a multimeter, I'm guessing, unless they happen to have marked it. And we'll see here in just a second if they did. Nice little enclosure. Oh, I didn't know it was actually going to be painted. That's a bonus. Okay, so here we go. So that is the PCB for the switch. Easy enough. This is the circuit board. So let's see. Well, unfortunately, it looks like they did not mark the actual schematic location. So R4, for example, is not marked on here, but 10K is. So there's advantages and disadvantages. If you're just going to part by part put stuff in and you just want a straight up Tubescreamer clone, that's pretty easy to do. That's probably the easiest way, rather than looking for R4, looking on the schematic for your R4 and trying to figure out, okay, if R4 says 10K, then I need to put 10K in this slot. So I understand why they did it this way, but for DIY purposes and for what we're going to do here, we are going to have to look at this and try to figure out, which resistor is, R2 here. What location here on the circuit board is it actually? So we're going to have to figure that out. So it's going to be a little bit slower of a process, but we'll get there. So a bit of an update here. I actually reached out to StewMac and explained what I was doing and said, do you have any sort of diagram that will help me do what I'm trying to do? So in other words, instead of showing 10K on the circuit board, do you have any sort of diagram that will say, well, this is actually, R2 right here? They're very responsive. They helped me quite a bit. I also found out that pedalpcb.com, great company to work with. I think they had a hand in designing this with StewMac. So they sent me another diagram of the circuit board, even though StewMac sent me this one right here, which does have everything labeled. I also received one from pedalpcb, and that looks like this right here. So it's actually, a little more clear to work with, which is handy. And what I found with a lot of these DIY kit companies, especially the better ones, and there's several others that are just really fantastic to work with. And you can always find the cheap kits, and they tend to not have this type of service. So if you're paying a little bit more for your kits, you're going to find that you're going to get this type of service a lot more than some $20 kit on eBay or something like that, or Amazon. They tend to not have the best service when it comes to something like that. Because if you don't have this sort of diagram, let me show you what you have to do. So at that point, you're looking at this circuit board right here and saying, okay, well, that's my in. What is the next resistor here? Meaning on this schematic, it actually goes to a capacitor and then a resistor. So I need to figure out which capacitor that is. And where is this capacitor at on this? Where do I find it at? And how do you do that? Well, you get a multimeter and you you put on the continuity setting. And basically when these touch, that tells you there's continuity. There is, it's zero resistance basically. So at that point, you're basically putting it on the in pad, putting one of the pins on the in pad, and you're just trying to figure out, okay, well, which capacitor is it? Those are resistors. So is it that? Nope, 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 nope. There it is. That's where it is. So you're basically going through this circuit board and you're trying to really, in effect, retrace the entire circuit on the circuit board. And really, we're still going to have to do a little bit of that, but with the diagram here, it's a lot easier because if we know, for example, that the circuit comes in, there's our in, here's our in right here, and it connects both with one end of R1, that's right here, and this leg of the capacitor on C1. Well, so now we can find where R1 is. So we know it's either going to be this or this, and we know that C1, we got to find C1 here. The C1 being right here. That signal is going to either hit this pad or this pad. Now we just have a few spots that we use with our multimeter to try to figure out, well, which one of these have continuity? Which one of them have zero resistance in between? So again, here's our input. Let's find where that resistor first crosses. Is it that? Nope. Okay, so it's that. So the signal goes from there to there. So that means that must be ground because we can see that on our schematic. Now, which leg of this capacitor right here also has continuity with this? It's not that one. There it is. So our signal both touches this point and it also touches this point right there. So looking back again at a partial schematic, and our diagram here. Again, we know that this is tied to this, and this is also tied to that. So basically, that's just showing that this signal path of the schematic is right here. That's these 3 points right there. Now, why is that important? Well, what that's going to allow us to do, since we're not putting a buffer in here, at least on my design, I'm not going to put a buffer in here. And there's a few different ways to go about this. There's not just one way, because we have some things on the circuit board that could be used in the same way. So here's what I mean. Since I'm ditching this buffer entirely, what I really need to do is get from this point of the circuit over to this point of the circuit. And I still need to bias this op amp here. And I can either do it through this resistor or this resistor. And it really doesn't matter which one. It's just whichever one I want to use. So they both do the same thing. They're both going through VREF. When I say they're doing the same thing, they're doing the same thing in the way that I'm going to use them here, which is biasing this op amp. How do I know that they're going to be biasing the op amp? Because it's a resistor from this signal path going into the input of this op amp to VREF. And if I'm attaching this to this, well, that means this resistor is going to be, attached to this, to the signal to VREF. So I don't need this. I don't need that, which means I don't need this. R4 is right here. So I don't need this. So these literally are just parts that I'm just going to leave out. But like I said, I do need to get the signal from here over to here. So what am I going to do? Well, I'm going to look up the pinout for that particular transistor. And I'm going to see, all right, here's where the collector is. Here's where the base is. Here's where the emitter is on the actual transistor itself. Now, this is something you're going to have to do for every transistor for any type of project you're working on, unless you just remember it off the top of your head. So in this one, the emitter is over here on number 1. The base is actually over here on number 3. And the collector is over here on number 2. Now, this is different than like the most typical transistor that we would use would be like a 2N5089. It's a different pinout. So if you're going to use a different transistor here, you're going to have to kind of bend the legs to move. So they won't work in that situation. So just keep in mind what the actual pinout is while we're doing this. So what that really means is that this right here is going to be this right here. So, and since that's already connected to the signal via a trace somewhere on this circuit board, then we're going to jump over C2 as well. We can see where the plus is here, so it means we need to connect to the minus. So we're literally just going to go, that's C2, we're just going to connect a wire from here to C2. It's just going to be a little jumper wire right there. All right, so something we need to do, I put my schematic here. This is the schematic that I'll be using. You can see it's pretty close, right? It's pretty close to what the actual Tubescreamer topology is. The main thing is that my values have changed. I'm not using an input buffer and some things like that to make it sound different. But one of the things that I'll need to change, for example, in the StewMac schematic, there's only 3 diodes for asymmetrical clipping. Well, I don't want that. But I do want 4 diodes, 2 going each way, because then basically at the end of the day, it gives the effect of less of a clean blend. There's different ways to do it. This is one way to do it where you just, have with the Tubescreamer type circuit, you generally have a bit of a clean blend in there. A lot of folks don't like it. I figured for this particular circuit, I would just kind of eliminate that as much as possible without using something like an inverting op amp or doing it a completely different way. So what that means is where D1 is, I'm going to have to physically connect 2 diodes together in series, so one going into the other. And that's going to allow me to use, to basically put 2 diodes where one diode, it will go on the circuit board. So that's D1. Let's look at D1 here. That means right here, instead of this one diode, it's going to have 2 diodes here. So it's going to go and a diode, another diode, and then go right back there to the other hole. And that's what it's going to look like. Even though that kind of looks like a pair of glasses on a bunch of capacitors, those are supposed to be diodes. So sorry, just pretend like they are. So I'm going to continue this way, going through this schematic, looking at this circuit board diagram up here, like we already did with the first part, just really taking that signal path and figuring out where it needs to go and what it needs to do. So since the schematic is pretty much the same, meaning we still have our low pass filter, we still have the same type of tone control, Same type of tone control, even though it's drawn out a little bit differently. Drawn out a little bit differently. It's still exactly the same thing. I did change some values there. So a little bit higher resistor there to give it the ability of having a little bit more highs. And I changed the values here because that just gives it a different sound and what I'm trying to do. So a lot of values being changed. Ultimately, the rest of the circuit, the topology, is pretty much the same. So we're still going through that output buffer. So we don't have to do any more of that trickery that we did at the beginning, getting around this input buffer. We don't have to do any more of that. That's the only quote unquote sort of mildly difficult thing that we have to do with the actual circuit board right here. And I'll put links below to all this type of stuff, so you don't have to screenshot anything. I'll put all the links below to the images and that sort of thing. Before we go on, let's talk about some mods that you can do to this type of circuit. Like maybe you're building this kit at the same time that I am. So with this schematic here, we'll go through the StewMac schematic. C4, let's say you want a little more bass, make C4 a little bit bigger. Want a little bit less bass, make it a little smaller. You're probably well aware of all different types of diode changes. You can always change these diodes around to different types, et cetera, et cetera. This right here, this low pass filter, of course, this is going to change things. Both this resistor, the value of that is going to change the low pass filtering, just like the capacitor is. Changing the value of that capacitor, also going to change all of that sort of thing. Same thing on the tone control, changing these values. It's going to change how this tone control works. It's going to change the frequencies that it's cutting and boosting. This resistor here is basically going to tell it, well, if you want it brighter, you better make this resistor a little bit bigger so there's more gain in that circuit. Gain in a technical sense, meaning it's boosting certain frequencies that are determined by these values right here. Boosting those more, the larger that resistor is. And then most of this other stuff is pretty common. So, they have an electrolytic capacitor right there. I'm probably going to use a film capacitor just because with this type of circuit, I tend to like a film capacitor right there rather than electrolytic. It really depends on the circuit, and it's, we're talking a 0.01% difference here. So it's not massive. If you only have electrolytics, then it'll be just fine. You're probably not going to notice a difference. Something else I'm going to do as well, I have these two schematics on circuitlab.com. I'm going to give these public access so you can tweak them and mess around with them all that you want. You can see my actual schematic. You can go in and start changing things. Like, let's say you want to make that a 10K. You can do that sort of thing and, save it as your own. I did write directions down right here, but one of the things we can do is we can simulate the circuit here. So let's say we want to simulate the tone. We write that out, that's the name of it right there. Start at 0, end at 1 with steps of 0.1. And let's see what the frequency does whenever you turn that control up in 10% increments. So that's kind of what it does. In 10% increments, that's the frequency of this with that tone control in that spot of the circuit. Now let's compare that with the Tubescreamer circuit, the stock Tubescreamer circuit. You can see that things just are completely different frequencies. So that's stock Tubescreamer. That's going to be what I do. So it's going to be a little bit more beefy around 400, 600, 800. Yeah, somewhere in that area. It's going to be a little bit more transparent, if you like to use that word. And it's not going to have as much of that clean signal because of the diode changes that we're doing. All right, so let's go build this thing. So here's, I guess, what you could call a little pro tip, but it's kind of hard to solder this little circuit board onto this switch because it wants to rock back and forth. So just get an old pedal box. I know this is probably sacrilegious to some, but just get an old pedal box, cut a little hole in it. That way that switch fits right down there, and now you have a good base to solder on. Okay, so something I noticed on this particular enclosure and something that I like to do, these holes here are where the jacks go. Just sort of like so. And since this little tab here, which is this, is going to sort of make the enclosure grounded, we want a really good connection right there. And since there's a little bit of paint over spray, what this means is we either need to use some heavy grit sandpaper and sand just sort of around that where this is going to attach, or maybe a file or something like that, and just kind of scuff it up so it makes a good ground connection. Will it work without doing this? Yeah, it'll work, but it's kind of better to do that. Now, at Wampler, what we do is we actually use some tape before we paint the enclosures. We just use tape over the holes. That way you don't have to grind anything, and that way it just makes a really good connection, grounds the enclosure really well. So, and I'll probably do it around the pots too, even though it looks like these particular pots are not grounded on the casing. Sometimes there's like a little ground tab that you can actually ground this little shaft as well. And just, kind of provides better noise characteristics, I suppose. A little less noisy, I guess, technically. And it's, again, not something you have to do, but it's a good thing to do. All right, so I don't want to do this over my parts and where I'm soldering, so I'm just kind of off to the side. And I'm just going to use this little grinder. It's actually a Dremel attachment, but on a drill. And I'm going to grind right here, just kind of around it. And then I'm just going to blow it out with some compressed air. Another quick tip is using pre-tinned wire. So this is the wire that StewMac gave me, and it is pre-tinned, so that's good stuff. I have my own, so I just use my own pre-tinned stranded wire. So I don't know if every kit does this. If it uses regular stranded wire, it's kind of a pain, like getting everything in the holes without it fraying everywhere, or possibly just a small little hair touching something it shouldn't. So if you get a kit that has just regular stranded wire, I probably would just get a little bit of pre-tinned from somewhere. Another little tip I just noticed, these pins here are the positive. So that's the signal positive. What I don't know is whenever I put that lid on, if they're going to ground on that lid. So I may need to either sort of turn these just a little bit so that doesn't contact this bottom plate potentially, or maybe I can just kind of bend them out of the way just a little bit. We don't want to bend them too much because we don't want it to interfere with the actual plug or the actual jack. the actual cable plug going through the jack. So we need to be careful, but it is something to keep in mind, something to, just be aware of as you're building these kits. Because if that does touch the ground, you won't have any signal. All right, so this is some interestingness. I put it together, tried it out. It did not work. So then, of course, the first thing I started doing was measuring voltages. I was measuring voltages with it plugged in, just kind of seeing like, why don't I have power? This was showing 0 power. I couldn't figure out what was going on. So I did the thing that I hate to do the absolute most. I hate this whenever you put a pedal together and you play it and you're like, oh my gosh, I can't figure out what it is just by looking at it. I now have to take it apart completely. That is, that's a type of hell for me. I don't like that. I pulled a breadboard module out, connected my power to my breadboard module. This is one made by our Arcadia, but we make one as well. And then I noticed, well, that's weird. With the different jack, I am getting power. It's not a problem. You can probably see that LED that's now working. And we can just kind of measure voltages here. Let's measure it off the pin that we know it's going to have on the op amp, 9 volts. So it should be working now. Voltages look correct, just simply with a different jack. And then I thought, I just want to see what happens whenever I, plug into the jack that was given with the kit. Because maybe something's wrong with the jack. With nothing plugged into it, this should read, backwards here. This should read 9 volts. It doesn't read 9 volts. It reads 0 volts, which means it's grounding out somehow, somewhere. I don't like that. That's very frustrating, but it does happen. And the only thing you can do is get a different jack. So I don't know if I have one of these types or not. If not, I'm gonna have to order one. But let's see if I can make something work. So here's the old one. Here's the new one. Let's see if this works. I'm pretty sure it will. All right, there's voltage. That's good. That means that's gonna work. So we can now continue installing this circuit back into its enclosure. Okay, so even though StewMac does include knobs, of course, I'm going to use my own knobs because, kind of like these and I don't really get a chance to use them that much on our pedals. So I'm going to use these knobs. I think these are actually Friedman knobs, or what, Friedman uses anyways. And of course, we have to label it in my favorite way, which is Sharpie. So if I had my way, I would pretty much label every pedal with a Sharpie. I know that's not like very, I don't know, cool, I guess. It's not very pretty. But man, I just really like homemade looking pedals. Just love them. I don't know why. Don't make the rules, but that's just the way things are. And what do we call this? I think we call this the not Screamer. Got to put my logo down here somewhere, right? Womp. And just for fun. Maybe I'll give this away. You know what? I probably ought to give this away to somebody because I may not ever use it. I don't know. I'll think about that here in just a minute. Well, we now have the pedal built. We have it next to the breadboard that includes the same exact circuit that's inside of this pedal now. And I'm going to run it through a different amp. So I just got this PRS. It's a HDRX, sort of a plexi styled. I think it's around 20 watts. Super affordable. Sounds fantastic. It's a great amp. I love this amp. So if you see one of these, check it out because it's really great. Well, I'll run it through this amp. And, we'll do a quick comparison between the two. So much fun to play. I probably overplayed a little bit right there, but it's a lot of fun to play it. I don't know what to tell you. So, all right. So if you like this type of stuff, make sure to check out my course, guitarpedalcourse.com. Use the coupon code YouTube15, YouTube15. That gets you, all undercase, all one word, that gets you 15% off any of the courses I have there, including the DIY course that will start to teach you how to do what I did here. Also, do you want this pedal? I think I'm actually going to give this away to, a lucky person that goes to this website. It's going to forward you to a Google form, but go to wamplerpedals.info, wamplerpedals.info. That's going to take you to a little form where you fill out your email address, your name, and your address. I'm going to pop it into this random name picker. And it tells you, it like randomly picks out a winner for you. It's for contests and that sort of thing. So it's just randomly going to be done. I'll pick out one person and I'll send you this pedal if you fill out that form and if the app picks you. So make sure to use a good email address because that's how I'm going to be contacting you. So if it's some flaky email address and you win, you'll never know. So overall, DIY stuff is super fun. I mean, and it's also a way that you can get classic pedals for super cheap, or much cheaper than you can other places, including some of my own. I've seen some of my own pedals on some of these kit type sites, or these sites like pedalpcb.com, where you can buy a PCB or kit that's basically structured around the circuitry of what you would find in something like Ours and many other pedals. So it's a huge way to just really dive in, get your fingers a little bit dirty, and maybe a little bit of soldering iron burns, maybe, and build something fun and cool, and really tailor it to what you want as well. That's another thing about learning this type of electronics is if you just learn the basics, the core structures, and kind of how things work, you could start to take these kits and turn them into something that you really want to hear. You can tailor it to the sounds that you have in your head. So, for example, if you don't like a Tubescreamer, just make it into something that you do like. And you can do that with the kit without having to, go and print out your own circuit board or whatever. You can just do that with a kit just by making some simple changes and knowing a little bit about electronics. So check out the site. Make sure you take advantage of that coupon code. Of course, comment below if you have any comments or questions, and I'll see you next time with a new video.